Ladies and gentlemen, Dan Kaufman, Director of Google ATAP.
Hey. Thank you. Good morning, everybody. I'm Dan Kaufman. 1 year ago, almost to this day, Google asked me to come and help lead ATAP. And I remember sitting in my hotel room watching the ATAP I/O presentation. And I was just fascinated with this idea that we could bridge the gap between our physical world and our digital lives. And I was moved by this insistence that we remember our humanity, that we take our human nature and embed it in technology, and I could not wait to come here. And now it's 1 year later, and I'm the head of ATAP, and I get to share with all of you some of the stuff we've been working on over the last year. And I could not be more excited. We have a completely packed show today. We're going to be like right up to the edge, and so I'm just going to give you a very brief overview of what we're going to do, and then we're just going to get to it. So one thing I get asked a lot when I go out around and I talk about ATAP is, what does success mean? How do you measure success? How do you know you're successful? What becomes success? So we'll talk a little bit about that. Then we're going to get you caught up and give you an update on projects Jacquard and Soli, 2 projects we showed extremely early. Yes, woo! We showed you some really early prototypes of that, and we're going to show you how it's made its journey as we've worked with some of you as developers and some commercial partners on its way to becoming a product. And then, of course, we got to talk about Aura. Who does not want to talk about Aura? Everybody wants to talk about Aura. Yes? So we got an update for you. And then finally, as has been our tradition over the last 2 years, we're going to end with a new Spotlight story. Except this year, we've got a really special twist. And I hope you like it. And I hope you like it. So let's first talk about success and what success means to us. And in order for me to tell you what success means for a project at ATAP, I have to take you back to the beginning. Everything at ATAP starts with a person and a passion and an idea. And that idea is often a little bit crazy. It sort of borders right on that line between what's possible and what's impossible. And so the first thing we do is we do a deep scientific dive to try to find out and make sure that it really lives within the realm of what's possible. And if we conclude that it does, then we dig in and we work on it, usually for a year, sometimes more, and it's hard. It's really hard. And it's hard because there's no precedence for what we do. There's just nothing out there like that before, and so we have to invent things. We have to invent new materials. We have to invent new testing rigs. We have to invent new software concepts. And we often hit roadblocks. And we stumble, and we fall, and we get back up again, and we fight, and we persist. And we do it because it's important and because we believe in this idea. And then something magical happens. We see this little glimmer of light at the end of the tunnel. And we think, holy cow, this thing that was just an idea may be real. And we go to the lab, and it's there, and it exists. And at that moment, we turn to developers, such as yourselves, and commercial partners, and we ask one simple question. If we can make this thing exist, not just in a lab, but in the real world, what would you do with it? What could you build? What products could it be? How could we impact people's lives? How do we get things into the hands of people? But most importantly, we ask them a simple question. Do you want to come on this journey with us? And when they say yes, things begin to change. They inject all sorts of new energy. They have all sorts of ideas. They want to take our technology places we never imagined. We encounter all sorts of new problems that we never thought of before. And more importantly, they come up with solutions to these problems that blow our minds. And all of a sudden, these fledgling ideas start to become prototypes. And prototypes become products. So success for us is when our projects make this transition. Because after all, for things to matter, people have to be able to use them. Now, these transitions happen in many different ways. I'm going to give you 3 brief examples. We've had a whole bunch of these, but 3 may give you a feel. So about 2 years on the I/O stage, Johnny Lee wondered if we could map the indoor world the same way Google can map the outside world. And he showed a couple of prototypes. Well, now with the help of Clay Bavor and the VR team, they took Tango from these early prototypes that we shared at I/O to a product you'll be able to buy later this year from Lenovo. Yeah, go buy one. Last year, we talked about Project Abacus. This was Deepak Chandra's vision to get rid of passwords and all the annoying things that we wanted. And he thought, gee, look, we have a phone, and these phones have all these sensors in them. Why couldn't it just know who I was? So I don't need a password. I should just be able to work. Well, thanks to our friends at Search and Machine Intelligence, they've taken these ideas, and they've turned it into a trust API. And what we're going to do with this is be able to get rid of the awkwardness of second-factor authentication. This June, we're going out to several very large financial institutions for initial testing. And assuming it goes well, this should become available to every Android developer around the world by the end of the year. I cannot wait to see what you guys build with it. Now, sometimes this transition, transitions don't happen on a schedule, right? Sometimes they just pop up and surprise you. And so I wanted to share this one with you because nobody's ever seen it outside of our shop. A while ago, we were looking at this slide, and this is a very complex slide, so don't worry about it. Here's the bottom line. There's an epidemic in congestive heart failure, and it costs us millions of lives and billions of dollars. And what we do today to help people with that is we do surgery, and we use what we call an invasive sensor. So you do surgery, and you put a sensor in the chest, and then it helps monitor people's health. And we saw this as a problem, and we wondered, if I could replace these invasive sensors with non-invasive sensors, wouldn't that be amazing? All of a sudden, the cost of healthcare would drop. We could give this to everybody. You wouldn't need surgery, which is risky. And we shared that vision with Andy Conrad and Jessica Mega, who were at the time all part of Google Life Sciences, now Verily. And they loved that vision. And so we've transitioned our people and our technology and the IP because we want to get this developed as fast as possible, and we could not think of anybody who's better off to do that. So hopefully you will get this in everybody's hands as soon as possible. So for us, that's what success looks like. Because after all, ideas are most meaningful when put into practice. So today, that's what I want to focus on. I want to focus on this journey that we take you on from an early idea to a prototype to just the beginning glimmers of a commercial application. So let's get started. Last year, Dr. Ivan Puparev introduced us to two projects, Project Soli and Project Jacquard. And over the past year, Ivan and his team have been working with commercial partners and developers. And to give you an idea of where we are on that journey, and for an update, Dr. Ivan Puparev.
Thank you, Dan. Good morning. So let's talk about Project Soli and Project Jacquard. In Project Jacquard, that we announced last year, we developed a new interactive textile technology to create connected clothes. We also announced partnership with Levi's. And there was a lot of speculation. Yeah, here you go. And there was a lot of speculation. What are we going to make with them? So let's take a look at one of them.
Apparently, Google's developing a new digital type of fabric that you can touch and it can feel it, and it also Bluetooths to your phone. So now you can swipe the side of your jeans to mute your phone, even tap the fabric for playing any song, which means pretty soon all your calls can be butt dials.
Butt dials? Seriously? That's $1 million idea for you. Almost accurate, except we're not making smart pants. No, folks, no smart pants. Instead, the very first Jacquard garment is going to be Levi's commuter trucker jacket. Fashionable and functional. Fashionable and functional garment to wear on and off the bike. And to tell you why commuter jacket is a perfect fit for Jacquard, I would like to invite on stage Paul Dillinger, VP of Innovation from Levi's. Welcome, Paul.
Thank you. Thank you. Thanks very much for that introduction, but we actually already met, right? It's hard to believe it was just a year ago at Google I/O 15 when we were first introduced. It's also hard to believe it's been 143 years since Levi Strauss first invented the blue jean. That's today, May 20th, is the actual official birthday of the blue jean. So for 143 years at Levi's, we've been making clothing with purpose. It started in the 1800s making durable clothing for the miners who'd come out for the gold rush. Fast forward to 2011, we first introduced our Levi's Commuter Collection. This is purposeful design, clothing built to meet the needs of the urban cyclist. But the formula has always been simple. Make a quality clothes that perform as great as they look. And so it's in that context I'm excited to talk to you about today's newest addition to the commuter family, which is the trucker jacket powered by Google's Jacquard technology. Anyone who rides a bike knows that tension. How do you go on a ride without going off grid? Anyone who rides a bike knows that it's a terrible idea to try to navigate the screen of your phone while you're navigating busy city streets. But this technology gives us a first-time real-world solution to that real-world problem. Now, if you imagine the opportunity for woven tactile interface in the context of the most explicit and urgent needs of an urban cyclist, that's safety and awareness, the opportunity becomes really real, really valuable. This becomes a co-pilot for your ride and for your life, both on and off the bike. This is a good friend helping you out. So now, to access the most necessary pieces of your digital life, you simply touch the sleeve of your jacket. This is a customized connectivity. This is maximized awareness and minimized distraction, and all of this without sacrificing the style of a great-looking Levi's trucker jacket. So now, if you want to answer a phone call or block a phone call, if you want to control your music, if you want to drop a pin to make your personal map of the city, if you want to access your navigation so you can get lost and then get found, all of that can be done with just a gesture, a tap, a swipe. Now, you might think that this kind of technology would be precious, but we're not making Levi's trucker gadgets. We're making trucker jackets, jean jackets. This is a tough technology. At the end of the day, you can just wad it up and throw it in your backpack. You don't have to hang it up. Just drop it on the floor. And if you get this thing dirty, you put it in the washing machine. This is friendly, easygoing technology. This is technology you can wash. But enough out of me. I think we should take a look at this jacket in action. So let's watch a video. I'm going to throw one on and come back and talk to you guys about some of the features, OK?
So Paul going to come back and show the jacket in a second. And before that, let's take a deeper look at what Google Jacquard is. Google Jacquard is a platform. It's not just another wearable. It's a platform to create smart, connected clothes. It consists of the garment with the woven gesture sensor somewhere in the cuff. A piece of electronic, Jacquard tag, which connects your jacket to the LED, haptics, IMU sensor, and also the battery to power the jacket. It uses custom connector in the cuff to do that. The Jacquard tag can be charged from any USB cable, so any USB computer, so you don't need a cable with the jacket. We also have a Jacquard app on the phone, which connects your jacket to services in the cloud. There is unique challenges in creating a smart clothing platform. Fashion and technology has to work as one, but there is inherent tension between the two. For example, when we designed our jacket for the first time, we were compromising garment aesthetics. The first design of the interactive area was like this, straight line. We engineers, we like things simple. Everything is visible, everything easy to understand. However, this is not denim. It was not authentic, and it didn't look good. So then we went the other way around and removed it completely and made it completely invisible. But now you cannot interact with that. So we were working with our craftsmen in Japan and Levi's and designed a new look, new denim weaving techniques, which blended gesture sensor into the fabric, made it both visible and invisible, while preserving an authentic denim look. In fashion, fit matters. You have to design technology which fits jackets of any size, from extra small to extra large, a problem we don't have in technology world. That's why our Jacquard tag is thin and flexible, so it can bend around cuff of any size and fit the jacket of any size. The design was inspired by the design of classic trench coat, and though it looks simple, it was a long road to make it just right. It has to be robust. Technology is fragile. Garments, as Paul mentioned, are not. Very durable. Now, these days, you don't have to pull them with 2 horses to prove that it really works. Those days are behind us. But at least you have to be able to wash it, at very least. In our first test, our yarns would break after 1 or 2 washes. So we went on and worked hard to understand the reason of the failure. We analyzed our yarns at the microscope and improved them to the point where we exceeded the Levi's requirements for jacket durability. We don't have to treat Jacquard jacket any differently from a regular jacket. Finally, clothes are made by apparel makers, not by consumer electronic makers. It's our vision that any apparel maker, not only Levi's, should be able to manufacture their own smart garments using Jacquard, using their own supply chain, because we want to empower the apparel industry to create this new product platform. So we were working with Levi's. We set up production in the same facilities and the same location as the regular Levi's production. We use the same denim looms and this exactly the same processes to weave our interactive denim. There was no exception. When you make denim, you burn excessive fiber with open flames. Our interactive technology went through the same thing. The final denim was shipped in the same assembly factory, the same treatments, the same construction techniques as a regular denim jacket, industrial washing. Every garment goes through that. Of course, we added some testing facilities to understand, quality control, see it works at the exit. But at the end, it's a regular jacket that feels good and makes you look great. I guess I want to say is that Jacquard jackets is foremost a jacket. It protects you from wind and rain, keeps you warm, and makes you look great. But it's much more than a jacket. As a user of this jacket, you will be able to configure it to connect to your favorite services, such as control calls and messages from the phone, or use your favorite Google services, Google Maps, Google Play, or others. You can use third-party services such as Spotify and Strava, and we're already working with third parties to include their support to the jacket. And finally, it can be custom services developed by you, by developers, and we will be releasing APIs to allow you to do that. Furthermore, we'll try to expand and go beyond biking, and we're going to work with athletics, business wear, and enterprise. But first thing first, our jacket is going to be released on the market in spring 2017. But you don't have to wait that long. And you can help us to improve the product by joining the beta in fall 2016. And now let's take a look at the jacket.
I'll set this right here. There we go. So it's a jean jacket, right? It's had some great formal modifications. The forms have been adapted to be most useful for the cyclist. For example, little things like the back's a little longer than the front, so you don't have that unfortunate gap when you're in your bike stance. It's also got a full flex extension in the back, so you've got maximum range of motion, and localized venting to keep you cool and comfortable on your ride. It's got a knit storm cuff right here so that it holds close against your wrist and doesn't let wind come up your sleeve when you're on your bike. But the real magic happens over here on this sleeve. So,
yeah, as you can see.
You can see fully responsive to the touch of the wearer against just the fabric. So there's a bunch of different things it can do. So Yvonne, let's pick a few that this will do.
Yeah. So this is applications which install the jacket right now. It includes Spotify, bird counter.
No, thank you. I don't need the bird counter today.
So we have music. We installed Music and Compass for you, so you can control this.
Music and Compass are pretty much all I need. I love to listen to music on my bike. I don't listen to this song, Riley, on my... There we go. That's my bike jam. Okay. Now, my next meeting after this is going to be over at Levi's Stadium. I know how to get there, but I'd just like to know how long it's going to take me.
Yeah, it's a good idea.
Your ETA is 41 minutes. You should arrive by 11:01 a.m.
All right.
I gotta go.
Okay, I gotta go. If I'm gonna make that ride, I gotta get out of here. All right.
Thank you very much. So with Jacquard, we created new materials that allow us to use embedded interactions in everyday objects, such as clothing. In our next project, Project Soli, we explore how can we use small set of fine finger gestures to control everything around us. In technical terms, Soli can be described as a small, tiny picker radar for gesture sensing. It's a radar, and we created new radar sensors running at 60 gigahertz that can track hand gesture using novel algorithms that we developed. The algorithm is extremely fine, allows to track really fine gestures, such as rubbing your fingers against each other, which allows us to create completely new gesture languages and gesture interfaces. So we develop a vision where your hand is the only control that you need. One moment is a virtual dial, or slider, or a button. And using these virtual controls, you should be able to control any device around you with the same set of gestures, wearables, speakers, or any other objects in the Internet of the Things world. We showed this vision last year at Google I/O and showed the proof of concept, and the potential of Soli captured people's imagination. It felt very futuristic, almost science fiction. So this year and after last Google I/O, we focused on bringing this science fiction vision into the reality to developers and to products. That was our goal. Our first step was to release the Soli development kit, which we did in October last year. And the kit included everything that you need to develop your products or projects. Hardware, software, libraries, documentations, everything you need. It was early work, so we selected about 60 developers from 180 applications coming from 14 countries. And we were quite encouraged by the diversity of the projects people built using our sensor. In this example, people using Soli to recognize materials, such as copper or milk or water. People use it for 3D imaging, predictive drawing in a touch interaction, in-car remote control, to lock and unlock your things, security and password with gestures, navigate visualizations, and compose and play music. So this is selection, very first few projects developed by developers using our Soli sensor. And developing and launching Soli for Alpha Dev Kit was an important milestone. It was the first of its kind, the first radar you can play in your own workshop or a research lab. However, it was just a first step. What we showed last year was designed to run in controlled environment, in a research lab, in a workshop. It can allow it to evaluate possibilities of the radar for interaction, but it cannot really build products with it. For example, it was using so much power that our legal department asked me to put this label on the back of the development kit. And although Soli chips was very small, they still require a large computer to run it. So it kind of defeats the purpose, small chip, giant computer. So to prove that Soli is not just a futuristic concept, it can work outside of the lab, we decided that by this Google I/O, not only we're going to improve it, but we're going to make it run it on a smartwatch. So the way I think about it, if you can make something run on a smartwatch, you can make it run any way you want. So setting this kind of goal, what it does, it creates such an impulse to the team that the progress is exponential, not incremental. For example, we had to drastically decrease size and power of the entire system. By working with our partners at Infineon, we completely redesigned a Soli chip. We optimized the radar control algorithms overall system architecture and reduced power consumption 22 times, from 1.2 watt to 54 milliwatt. And this is just the first step in our optimization. We also reduced footprint by 3 times, Now, reducing power is not sufficient. As I mentioned, there's a giant computer that runs the Soli. So we also had to optimize computation. Now, radars are naturally very computationally expensive, often require a supercomputer for the imaging and tracking, when you're tracking satellites or planes or something like that. Now, we don't have supercomputer. This is our embedded platform. It uses the same processors as a watch. So by optimizing our signal processing pipeline and algorithms, we were able to achieve 256 reduction in code performance, while maintaining 80,000 frames per second throughput of the radar. So you don't have to compromise your performance for small form factor. And by the way, it's all runs on Android. However, nothing is free in this world, and there are trade-offs. And I want to talk about one of them. With every hardware reduction, with every improvement of our algorithms, we change the radar signal. And this is something which is called glitch zoo, a collection of signal artifacts that we discover and have to find a workaround. Some of them are well-known in research literature, such as IQ channel imbalance, Doppler mirror images, ghost targets. But a lot of these glitches are new and the result of our aggressive reduction of hardware and software. So this is ongoing research and development work. Now, I can talk more about these challenges and the problems, but let us get to the watch. Let's show the watch. This is the first watch we developed. Doesn't look like a watch. Working with our partners in LG Electronics company, from LG Electronics research team, we actually built the first watch, and it looked like that. At this time, radar was embedded into the band, into the belt of the watch. We still didn't feel it looks like a watch. You still have to have this black thing which doesn't bend around your wrist. So we went on and shrink radar hardware further. So this is very tiny chip on the left. And here it is, a watch with Soli radar inside. And I have it on my wrist too. It can even show time. That's how awesome technology is. So now our goal is not to create just a smartwatch, but to create unique interactions. And I would like to invite Nick Gillian, our lead machine learning engineer, to show how it works. But before he shows it, let me kind of give you a preview of what you're going to be seeing on the screen. What Soli allows us to do is to expand interaction of the touch screen into the 3D space around it. So you don't have to use a tiny screen to interact with your watch. You don't have to try to hit small targets. Use the whole space around the watch to interact. So we split the space in two big parts. To interact with information on the watch, we're using large gestures around the watch. So you can move your hand like this, and you can scroll through messages or see parts of the interface, part of information. And if you want to navigate the interface of the watch, you can use virtual tools, as we talked before, virtual dials and virtual buttons. So you can put your hand next to the watch and use them to navigate interaction and interface elements. So let's take a look how it works, and I'm asking Nick Gillian to show it. Nick, up to you.
Thank you. OK, so let's take a look at the watch. You can see, as my hand approaches, it dynamically starts to react. Note how the responsiveness and precision of radar enables us to create these continuous fluid interactions. The blue bar here you can see corresponds to my proximity to the device. This enables me to glance at information at a distance. So here, for example, I can see I've got 4 unread messages. If I come a little closer, I can now see the names of the users who sent them. The precision of Soli enables me to interact with minute detail, such as this scrolling typography. If I move a little closer, I can now preview the contents of the first message. You can see how Soli allows us to take the contents on the display and actually move them to the space around the watch. And if I remove my hand, it dynamically resets. OK, but what if I want to interact with more detail? That's easy. I just move my hand closer to the watch. And now, I can use a virtual dial gesture to interact with the complications. So here you can see I'm using a virtual dial gesture to rotate through these various complications. So we've got the messages, the weather, and the calendar. These gestures represent interactions with physical controls, such as using an analog dial. Because I don't have to touch the screen, we can get a lot more information on the display. And of course, just because they're micro gestures doesn't mean I have to do them right next to the device. They also work at a distance. So let's select one of the other applications, the weather, for example. I'll remove my hand, and now when I come back in, I can instantly look at what the next weather information is. So you can see, with just a few Soli gestures, we can already start to build these rich interactions. Soli embedded fully on a smartwatch. Back to you, Van.
So Nick, stay on stage. We have another demo. Nick, you're going to show it. You're very good at that. So we didn't build Soli just for smartwatches. We think it as a generic interaction platform to control all sorts of devices with a very simple set of simple gestures. So to explore the use of Soli beyond the wearables, we decided to take it to the living room in collaboration with Harman and their JBL brand. So here, Soli allows to control home devices from the distance without touching them. This is the very first prototype. It's here with a speaker, very early work. But the idea here is exactly the same interaction principles and the same gestures that we designed for watch also allow us to control the speaker. You can see. Woo. It's a different embodiment, but the principle is the same. As you're approaching his hand, you can see that the speaker recognizes it and reacts to it. So what are you going to do next, Nick?
Yeah. So note that the interactions here are much larger than the watch. They're several feet. The sensor actually can sense up to around 15 meters. So we can do some pretty amazing stuff with this. And this is the same thing that's in the watch. Okay.
Same algorithms.
So as I approach, I can now use the virtual tool to turn it on. OK, let's try another track. What do you think? Next one? Yeah, that's pretty cool. OK. But I can also do other gestures, more immediate ones, like shut it up.
Great. Yeah. Thank you very much.
Cool. Thanks so much.
Thank you to Nick. So to conclude, Soli is an interaction platform for connected world. It proposes new universal interaction experience across multiple connected products of the future. It can be wearable, mobile, Internet of Things, automotive, industrial. It's all up to your imagination. What it does, it offers a third dimension of interaction which complements and enhances other interaction modalities, such as touchscreen and voice input. We don't fight with them. We work together. And working with our partners, such as Harman, LG, Infineon, and others, we want to bring this new experience to products. But you don't have to wait until it becomes a product. Next year, we're launching the next version of the Soli development kit, the Soli Beta Dev Kit. And that will be embedded, low power, and based on modular design. So what you're going to have is Soli going to be this size, and you can put it in your products or projects and explore the use of Soli in your ideas, in our designs. So we're looking forward to exploring Soli with you. And that was Soli. Thank you.
Pretty cool, yeah? So thanks to Nick and Yvonne and Paul, but like mostly thanks to Levi's. Do I have the coolest job in the world or what? All right, so I promised you we would talk about Aura. And for those of you who may be new here, Aura is our vision for the future of phones. And even more so, our vision for an entirely new hardware ecosystem. For those of you who've been following Aura for a while, you may be wondering, what's going on with Aura? Where is it? And most importantly, when do I get one? Yeah, woo. So, well, ARA has made so much progress over the year, and we've talked about this journey from concept to prototype to product. It's made so much progress this year, it's actually spun out into its own business unit. It's spinning out of ARA into another business unit inside of Google with our boss, Rick, who's here. Thanks for coming. And it's going to be run by Richard Woolridge. And here to tell you more about it and the progress that we've made, Rafa Camargo. Sorry.
Thank you, Dan. All right. For the last year, we've been working with users, developers, and partners. As a result, we've implemented a new set of technologies to create a seamless modular experience. Most importantly, we put modularity where it counts. Let's take a look. This is the developer's edition of ARA. We've integrated the phone technology in the frame that frees up space for modules that will create and integrate new functionality that you cannot get on your smartphone today. It has 6 modular slots. They're built for flexibility. You can put any module anywhere. All slots are generic and support any functionality. Each slot supports up to 11.6 gigabits per second while consuming 1/3 of the USB 3 power. They are interconnected via a UniPro network. That allows you, for example, to route raw 4K video directly to a computer vision coprocessor for real-time processing. It's ready for the most advanced high-performance applications. Modules are designed to work with a variety of form factors. Future frames can be larger, they can be smaller, or something completely different than a smartphone. Current modules will work with feature frames. Future modules will work with current frames, protecting the investment of both users and developers in modules. All right, so how do you add functionality to your ARA? Step 1, plug in a module. Step 2, use it. Okay, guys, smile. There you go. It's that simple. It's that easy. No rebooting your device. No hunting for drivers. And how do you reboot a module? Well, you select the module you want to release from the settings up. Just tap it. And then when I turn it so it doesn't fall, it's just going to pop. Oh. I may have gone too fast on that. Let me try that again. Let's try a different way. OK, Google, eject the camera. There you go. Let me put it back. Over this last year, all right. Over this last year, we've built a tech not just for a smartphone, but for a truly modular computing platform. Our silicon has implemented the world's first UniPro network. High speed, low power, and application independent, future-proof, and designed from the ground up for mobile. The module connector is built for the speed of UniPro and is robust, up to 10,000 connect cycles. And the electromechanical latch built with nitinol memory alloy and control from software, as you just saw, creating an intuitive module release experience. Graybus, the ARA software stack, enables runtime detection and use of modules. You just plug it, and it works. And we have abstracted all this technology in a base plate. So developers can focus on their technology, while users will be guaranteed a consistent user experience when using ARA modules. The base plate is the hardware equivalent of a software API. ARA is an open platform. We want to create a hardware ecosystem on the scale of the software app ecosystem. And to talk about what we're doing with modules and what's next with ARA, here's Blaise Bertrand, our head of creative.
Thank you, Rafa. Good morning, everybody. So as we've been developing the phone, we've also been creating modules. And we started with modules that improve current phone functionalities: better speakers, high-resolution camera, and expandable storage. But we also wanted to make ARA personal. So we've developed modules with wood, modules with concrete, and modules we added color to it. We've also been exploring secondary displays, various types of sensors, and new technologies that you can't find on phones today. ARA is the combination of beauty and function. But it's also about solving specific user needs. Diabetes. Over 6 million adult Americans who have diabetes check their glucose level several times a day. Okay? And for that, they have to carry many devices: a phone and a glucometer. Well, it turns out that pretty much everything in a glucometer, besides a few sensors, is also in a phone. So we thought, hey, what if we could put all this into a module to create a better glucometer? Well, you know, it'd be in your phone, so it'd be a lot more compact, right? And you could also add context to your measurement by showing, for instance, if a reading was done after sitting or after exercising. Now, the great news with ARA is that we don't have to go it alone. As a matter of fact, we've been partnering with best-in-class companies to develop modules with us. Companies that are already familiar with the mobile space: Samsung Electromechanics, Micron, Sony Picture Home Entertainment, E-Ink, Panasonic, Wistron, TDK, Toshiba, and Harman. But other great companies that have built great products and never had the chance and the opportunity to have their technology on phones. Companies like Cohero, iHealth, Backtrack, and Gotena. So now we have a phone, we have a set of modules, and we have great market partners. Well, now we need your help. So later this year, we'll be launching the developer edition of ARA. It will contain a phone, a few modules, well, essentially anything you need to start building. So we'd like to ask you to think about what are the modules that you want to create. But there's more to come. We've been working on the consumer version of ARA. It'll be thin, it'll be light, it'll be beautiful. And we'll launch it next year. Meanwhile, I'd like to give you a glimpse of what life with ARA could be like. Thank you.
So thanks to Rafa and Blaise, but you know, Rafa and I have worked together for a while, and you think he would know a lot better than this, because he always says the key is making ARA yours, and he left it up here, and well, ARA is now mine. Thank you. So, as we said, we wanted to end the show with talking a little bit about spotlight stories. And one of the reasons we want to do that is a core tenet of ATAP is to remember not to lose the human inside of all this technological wonder. And 2 years ago at AI, Disney legend Glenn Keane enchanted all of us as he drew on stage and brought to life Duet before our very eyes. And last year, we had Justin Lin's live-action Alien take over LA in 360, and that shook our I.O. session. Well, this year, we have a really special treat for you, but I can think of no better way to talk about our latest spotlight story than just introducing Rashid Al-Gharab.
Thank you, Dan. Thank you. So 2016 has been a big year for 360 and VR. Enthusiasts have their early headsets, and 360 video and cameras are now becoming mainstream. The one question that keeps coming up over and over is, can we tell stories in this new medium? Can we make films like the ones we love and the ones that move us? And we've been working on this for a while now, before 360 cameras and before the new VR. And besides all the efforts for capturing or creating immersive worlds around you, we cannot forget one important and essential factor in storytelling. That stories have setups, complications, resolutions. They have beginnings, middles, and ends that need to make sense. And a structure without which we're easily confused or maybe not interested. And what's most important for being able to tell a story to an audience is managing their attention. It's easy for me to get your attention right now. I'm here on the stage, and you're sitting in your chairs facing the right way, and you know that the next thing is going to happen here. But when you're immersed in a story, it's all around you. But how do we tell you where should you look? How do we tell you where the next thing is going to happen? How do we keep you from getting lost or just missing an important moment in the story? Google Spotlight Stories came out of this challenge of being able to create immersive stories with a structured narrative and giving filmmakers the tools so they can get the right impact from their story, even when you, the viewer, are in control of the camera. And we do that through interactive techniques that are tuned to manage and respond to your attention as you're watching without you noticing. Call it attentioneering. Let me give you some examples. Our stories will wait for you to look the right way. And where it's easy to get lost in a big 360 video, our camera will dynamically guide you, without taking control, to get the best framing for the action. Like here, we see you're interested in this monster, and so we'll keep you on it. And if you get lost in the clouds, we will not only reward you with a change of music, but a helpful actor will come over and help you and guide you back to the main story. And if you're just still curious and want to look around, well, you might discover subplots, gags, and other scenes, because this world is alive around you. Sometimes you have to watch over and over before you get all of them. And we know these techniques work because we partnered with award-winning filmmakers, masters of their craft, and we created actual films in CG animation, in classic hand-drawn animation, and even Hollywood-scale live action. And with our story development kit, award-winning studios use these and other techniques to create their own films and push immersive storytelling even further, without one line of code. In 3 years, 8 immersive interactive films with different styles and different voices. It's a VR film festival. Now, with the enthusiastic reception from the animation and film communities, but more importantly, millions of people have already experienced these stories through the window of a phone screen, with VR viewers like Cardboard, and now with big VR headsets. All these different films run on a tiny but powerful game engine, doing real-time graphics and animation, 360 video and audio, and enabling film-like content in real time on mobile hardware. This engine was squeezed to less than 1 megabyte of code, smaller than a codec, and was delivered to billions of devices on one of the largest online video platforms, YouTube, where these interactive, nonlinear films are as accessible as a regular video. Now, last Christmas, we launched our first YouTube interactive short called Special Delivery from renowned studio Aardman Animations. Unlike a linear video, the full environment of the show had to be streamed and reconstructed on your device in less than 1 second, because it's 3D and it's real time, and you can look anywhere from the first moment you see it. With our latest story, we pushed our compression and nonlinear streaming techniques way further. 26 different environments, each one bigger than the whole of the other story. Each one lasting only for a few seconds. And this is the first show where we continuously cut from one shot to the next, 38 shots in less than 6 minutes. And the engine has to throw away a full environment every time and bring in a new one each time, seamlessly, perfect sync, without a hitch. And more so, with 4 ambisonic tracks, specialized music and stereo music, and 3D positional audio, this was the most complex and rewarding sound experience we've ever created. The story is called Pearl, and is premiering today on YouTube. Now, before you go check it out, I would like you to hear from the director himself. He's known for animation on big Disney films like Wreck-It Ralph, Tangled, and Big Hero 6. And he was supervising animator on an Academy Award-winning short called Paperman. Last year, he picked up his own Academy Award for a beautiful animated short called Feast. And of course, what do you do after you win an Academy Award? You make a spotlight story. So, ladies and gentlemen, the creator of Pearl, Patrick Osborne.
Thanks, Rashid. So a little over a year ago, I showed up for my first time at Google, right down the street here, and met the amazing minds at ATAP. And I took over one of their famed whiteboard-covered conference rooms and began to draw up an idea. And I wanted to make something memorable, beautiful, and maybe meaningful. And I didn't know it then, but I was very lucky to have met this particular group, these geniuses at ATAP, because I didn't know it yet, but I was asking for something that was really hard, maybe impossible to do. I wanted to make this short, Pearl, a 6-minute, fully animated, 360-degree short road trip musical that takes place entirely in a beat-up 1980s sedan with 15 characters, more environments than many feature films. And just designing and creating that many sets is a lot to handle. But on top of that, they need to be rendered in real time on a phone. And apparently that's hard. So my background is in animation, and I've been working in feature films for the last 13 years. And animators are control freaks. We make everything from scratch in every scene. But this mobile platform was different. It was going to be a film without a frame. The audience, not me, the director, gets to decide where the camera goes, and that feels like a lot of control to give up at first. But I thought about maybe turning those limitations into something that would inspire the story. So filmmakers have been using artificial frames within frames since the beginning of time, or beginning of film. If we set this film entirely in a car, I could get my fill of these pretty compositions by making frames with the car windows themselves. So what kind of story takes place in a car? I love road trip movies, so I thought maybe we'd make one of those. And we'd let the audience sit in the passenger seat and treat it more like theater than film, where I try to spotlight the action and direct the attention of the audience, but it's completely okay if they wander, and I made sure the story would read no matter what direction they were looking, even if you're not looking the right way. So it would be some sort of road trip, giving tree kind of story, maybe a story about passing down your car. And I thought, what else do we pass on? Personality, tastes, and talent, maybe. I used to draw with my dad as a kid. He's a toy designer. And I think more than any of the physical things he gave me, including my high school '89 Civic hatchback, the thing I value most is the time we spent together drawing when I was a kid. He passed on a sense of visual taste and the love of putting pen to paper. And I think, considering what I do now, it's probably the most valuable thing he ever gave me. So I decided to make Pearl that, a story about passing on an object, your car, but also handing down a passion or a talent. In this case, not drawing, it was going to be music. It was going to be a musical. So it's going to be a musical. We need a song to wrap the whole story around. And I decided to structure the story like a pop song itself, like verse, chorus, bridge. And this is a little chart that I handed over to the composers at Pollen Music to explain that. I don't know how clear it exactly is, but it was to guide them through this structure and this idea of how that song would be made. So J.J. Weisler and Alexis Hart wrote the beautiful original song, No Wrong Way Home, and it was performed in the short by Kelly Stoltz and Nikki Bloom. Now, of course, Pearl is out there in the world right now. You could pull out your phone and watch it on YouTube. But the song being such a core, central part of the story, I figured it'd be really cool for I.O. to actually bring Kelly and Nikki here and do it live for all you guys here and for the world.
Hello.
Hello.
So enjoy No Wrong Way Home.
I hope your dreams don't feel small. And when the wind begins to rise, I hope your mast stands straight and tall. These are fragile times. We blur the lines. The unlikeliest of places, we all find a little grace. There's no wrong way home. The spiraled shell, the golden mean. You see, you're just the sum of those who have been down this road before. You were expecting more. It won't hurt to rest a while. The soft shoulder by your side. It ain't where you've been, but it's where you're going to. It's not where you're from, but where you belong. And there's no wrong way home. There's no wrong way home.
One prayed for laughter and one for fear. Well, I tied them both together 'cause it was always windy here. And don't take this wrong, but I never knew you were watching over me, or was I watching over you? And it ain't where you've been,
but it's
where you're
going to. It's not where you're from, but where you belong. There's no wrong way home.
So I hope your plans accounted for rain. I hope you stashed a few dreams where you might find them once again. These are the best of days. It never feels that way, but it's in the rearview mirror that these things become clearer. There's no wrong way home.
There's no wrong way home.
There is no way to finish that, so we're just going to say thanks, and we'll see you next year at I.O.